Hi everybody, welcome to lecture number 7, Internet Protocol V4 V6 Interoperability. So in this lecture we are going to discuss about what are the various interoperability techniques available to handle V4 and V6. So basically there are three different techniques available. So we are going to discuss all the three techniques. Then we are going to discuss about the drawbacks. Okay, what is the drawbacks of each and every technique. Okay, so what we are going to cover in this lecture means introduction. So basic introduction, that means what is IPv6. So already IPv4 we already discussed, so no need to go for any introduction about IPv4. IPv6 we are going to give a small introduction. So then we are going for address, categories and types. So what are the different categories of IP address available in IPv6? What are the types of IP address available in IPv6? Then we are going for the core part. So the core part is going to be the transition mechanisms. Okay, so there are three different techniques we are going to discuss here, and finally some issues we are going to discuss. Now, facts and figures. So what is facts and figures means? We are moving from IPv4 to IPv6. Okay, so what is the reason? Means the number of users, that means the internet users are growing every day. Okay, so previously we were using only the desktop PCs, then we just moved on to the laptops. Now we are having the mobile phones. So after the invention of the mobile phone, so the number of internet users were raised like anything. So we need more number of IP address to support more number of internet users. So this is one of the major reason. So internet users growing extremely fast. So because of that, IPv4 addresses is completely exhausted. It is completely over. Okay, so IPv4 addresses it is completely exhausted. So we are going for IPv6. So IPv6 it's a very it is going to provide a huge number of IP address. Okay, for example, if you take IPv4, so the total number of IP address is 2 to the power of 32. Okay, roughly. But if you go for IPv6, it is going to be 2 to the power of 128. Okay, so there is a huge number of IP address we are going to get while comparing with IPv4. IPv6 is going to have a huge number of IP address. But both IPv4 and IPv6, it is coexist, okay, for a particular period. Then gradually IPv4 will be replaced by IPv6. So if you can see in your network. Okay, what type of IP address you are using means, so some they may tell, okay, we are using IPv4. So some networks it is already they implemented IPv6. Okay, some IPv4, some IPv6. So it is now we are in a period where both are in use. So 4 is also in use and IPv6 also in use. Okay, so we are in a period, it is a transition period. But if you see after 5 years or 10 years, after a particular period of time, completely IPv4 will be removed and everybody will be having IPv6. Okay, networks or devices which is supporting IPv6. So this is about the facts. Now, if you take IPv6 categories, there are three different categories available. So one is a unicast, multicast and anycast. So here there is no broadcasting concept. Broadcasting concept has been completely removed from IPv6. So unicast. So unicast means here it is going to be one-to-one, a single source, a single destination. That means only one interface will be identified as a destination. So the packet will be delivered only for that particular destination. So that is unicast. So if you are going for multicast, multicast means in a very simple way, it is going to be one-to-many. So a group or a set. Okay, so a group of interfaces, those who are interested in a particular point, interested in a particular application. So they are going to join a group, okay, a multicast group they are going to make it. So the data will be delivered only for that particular group or that particular set of devices. Okay, so this is called multicast. I am going for anycast. It is almost same like multicast, but what is the difference means? Okay, a set will be available, a group of users or interfaces will be available here, identified. But the data will be delivered, the packet will be delivered only to the nearest host. Okay, the nearest host to the source. So the nearest host will deliver the data or the message or packet, you can use any word. So the data will be delivered by the nearest host, okay, to all the others in the group. So this is called anycast. So one to one to many. Okay, so one to one to many. So this is going to be the anycast concept. So these are the three different categories of IPv6 addresses. Now, if you are going for IPv6 types, the next one, IPv6 address types. It's a very big collection. If you go for IPv4, we are having classes, class A, class B, class C, class D, class E. There is some range available, so you may know already that. So class A, class B, class C, class D and E. So this is going to be the different classes. Then if you take each class, that means A, B, C, there are private IP address, public IP address. In class A, there is a private IP address, class B, private IP address, public IP address, class C, public IP address, private IP address. Only this is the thing we have. But whereas in IPv6, we have lot of different types of IP addresses. So basically, multicast, unicast and anycast. So if you are going for unicast IP address, okay, so we have another 5 types available. So the first one is a unspecified loopback. Okay, about all these types we are going to discuss in some other lecture, okay, about IPv6 addressing. So the first type is unspecified loopback, link local, aggregate global, site local, IPv4 compatible. So these are all the unicast addresses. So in multicast we have two, one is the assign and second one is solicited node. If you are going for anycast, we have 3 different types, link local, aggregate global and site local. Okay, so these are the different types of IPv6 addresses. Now, major changes. What are the major changes from IPv4? Okay, that means in IPv6 we can say these are all the features or the characteristics of IPv6. Okay, so the first one is larger address space. Yes, in IPv4 it is 2 to the power of 32, but here it is 2 to the power of 128. So you are having more address available. That means IPv6 addresses, more number of IP addresses, a very large address space is available here. Then it is having a hierarchical address space. So there will be some hierarchy will be maintained. Then hierarchical assignment of unicast addresses. This is what we discussed in the previous slide. So there is a hierarchy of addresses will be maintained here. Then better support for non-unicast addressing. So other than unicast, okay, other than unicast, so it is supporting multicast and also anycast it is supporting. Then auto configuration and renumbering concepts. Okay, there are different methods of available. Okay, there is a very popular method Slack. Okay, in IPv6. So different methods of auto configuration is available. Okay, which uses of EUI. Okay, EUI 64 method is available. It's a very interesting method. So there are different auto configuration techniques available. Okay, for IPv6. Then the datagram format. That means the format of the IPv6 format is different from the IPv4. Okay, all the unnecessary fields, okay, it is moved down. Okay, only the necessary fields, okay, they shifted the places. If you see the format of the IPv4 and IPv6 datagram, okay, you can see there is a change in the places. So many fields in IPv4, it is moved down in the IPv6. Then support for quality of service. So in IPv6, so the quality of service is very much implemented. Okay, so that means you can distinguish the packets. Okay, you can distinguish the packets. Okay, this packet is an important packet or a very simple, very urgent packet. So this packet is carrying the voice data. So you can have some differentiation there. Okay, among the packets. And security is also available inbuilt. Okay, it's with IPsec. Okay, IP security. Then updated fragmentation and reassembling. So fragmentation means, that means converting, that means making the data into pieces. Okay, fragmentation techniques and reassembling techniques. Okay, it's updated. Then lot of procedures available. Modernized routing supports. Okay, that means IPv6 packets, it is different protocols available. If you take the normal protocol, okay, we know about the normal protocols like RIP protocol, IGRP protocol, okay, EIGRP protocol, OSPF, okay, which is in the IPv4 network. So if you are going for the IPv6 network, so we have some specialized protocols, okay, there, okay, OSPF v3, okay, like that. There are different protocols available for IPv6 itself. Then transition capabilities. So this transition capability today we are going to discuss in this lecture. There are 3 things available. So how you can move from IPv4 to IPv6, IPv6 to IPv4. Okay, so these are all the transition things. We are going to discuss it coming slides. So what we discussed here, major changes from IPv4. Okay, so these are all the features which are available in IPv6. Now I'm going for the next one, which is the interoperability techniques. So this is how you can handle both IPv4 and IPv6. Okay, for example, I'm having a IPv4 network and my friend is having IPv6 network. Okay, so I want to send some data from my network to my friends. Okay, so this is from IPv4 to IPv6. I want to move the data. The same thing, vice versa. From IPv6 network to a IPv4 network, I want to send and receive data, send and receive. So in that case, how you can handle means you are having some techniques. Okay, there are 3 different interoperability techniques available. So the first technique is the dual stack techniques. Then the second one is the tunneling techniques. Third one, it is the translation techniques. So there are 3 different techniques available. So depending upon the need or depending upon the scenario, you can use this technique. Okay, now in one line, what is a dual stack? So dual stack means both IPv4 and 6 will be available at the same time. Okay, so in a single machine or in a single router, so both the protocol will be running, both 4 and 6. Okay, so run both IPv4 and 6 at the same time. So this is going to add some overhead. Because of this, some drawbacks available. So what are the drawbacks? Everything we are going to discuss in the coming slides. Now this is a temporary solution. It is not going to be a permanent solution. Dual stack is not a permanent solution. So if you are using dual stack means, okay, you are doing a particular job twice. Okay, in IPv4 you are going to do the same thing, and in IPv6 you are going to do the same thing. So it is an unnecessary one. So you can remove any one. Okay, either you have to go with any one, that means 6 or 4. So using both, it is going to increase the overhead. So many resources will be wasted here. Okay, this is one of the drawback, but still we are going to see what are the drawbacks of dual stack in the coming slides. Now the second one is tunneling technique. So here we are going to use a concept called tunneling. Okay, so that means like encapsulation will be available. So here you can do the tunneling and you can send the data, that means the packet, from one network to another network. Okay, so this is going to be the tunneling one, we will see later. Then translation technique. So this is going to be converting. Okay, from 4 to 6 or 6 to 4. Okay, we are going to do some conversions. So that is going to be the translation techniques. So these are the 3 different interoperability techniques available to handle both 4 and 6. Okay, to handle both 4 and 6. Now let me go for the first technique, which is a dual stack. Okay, dual stack technique. So in the dual stack technique, you can see here. So this is a single router. So this router is going to support both the IP addresses. It is going to have both IPv4 and IPv6 address. So the same thing here. So R2, here we are having an interface. So I configured both the IP address. So IPv4 address and also IPv6 addresses I am going to have. So this is called the dual stack concept. So this is an integration method in which a node has connectivity to both 4 and 6 networks. So 2 protocols will be running at the same time. So 2 stacks can be on the same interface. So suppose this is a serial interface. Okay, serial 0 by 0. So the serial 0 by 0 is now configured with 2 protocols, IPv4 and IPv6. Then choose with the stack to use based on the destination address. The node should prefer the IPv6 when available. So based on the situation, if you are sending a IPv4 packet, so IPv4 will work. Okay, if it is receiving a IPv6 packet, so IPv6 address will be enabled. So depending upon the situation, it will use. And this is a commonly used method, but this method is not a permanent solution. So it is not a permanent one. Okay, so either we have to go for 6 or we have to stay in 4. But 100% sure people will move to 6. Okay, IPv6 in future. Now, so if you see here, so if you are going for the dual stack, there are some applications which is already built by using the IPv4 concept or applications which will run on IPv4 networks. Okay, we have some applications. So this all applications must be modified. Okay, it should be modified. But nowadays, the programmers, we can say the programmers or software developers, they are making the applications for both IPv4 and 6. A single application can run on both, okay, 4 and 6. Okay, some applications you can convert from 4 to 6, you can convert. So what we are understanding from this means, so you must have a different set of applications. For IPv4, a different set of protocols, a different set of applications, apps you need. For 6, you need a different set of protocols and different set of applications. Okay, so this is the concept. So these are all, we can say it is a drawback also. Okay, it's a drawback also. But I hope definitely this will be overcome. We will overcome all these issues in the next 4 years or 5 years of time. Okay, so people definitely they will forget 4 and everybody will move on to 6. So only 6 will be available in the future. So if you see the drawback, what are the drawbacks now? We will discuss the drawbacks. So a drawback of dual stack is resource is required within each device configured with both protocols. So we need additional resources. So you need the processor, memory, etc. to handle both the protocols at the same time. Then you need to maintain two different protocols, two different routing tables. If it is a router layer 3 device, so two different routing protocols it is going to manage. So one is a dual routing tables, one is for the IPv4 and another one is for IPv6. So the resources required here and also the load, okay, and also the overhead. Okay, if you see the overhead or the load of a particular device will be higher. Okay, so a router is having both IPv4 and 6 if it is supporting, means two different tables it is going to construct, routing tables. One is for IPv4 routing table and another one is going to be IPv6 routing table. So this is the drawback here. Then there is no higher administrative overhead, there is also higher administrative overhead. So administration also is going to be a difficult one, and troubleshooting also it's an issue. Okay, and then monitoring and also on more complex things. So handling both is not recommendable, it's not advisable. It is having some drawbacks. Okay, there are some technical drawbacks available in handling both. Then so IPv4 and 6 have different software requirements to run. So this is what we discussed before. So if you take IPv4, so you need OSPF v2 version 2 OSPF protocol v2 we need for IPv4 networks. So if it is IPv6 networks, we need v3. So a different set of protocols are needed, okay, for IPv6 and different set of protocols for IPv4, and both must run on the same device. So that is going to be the problem here. So in dual stack exchange, the device is configured in only one stack and most forward to the dual stack devices. For example, routers and then back to the same segment using the other stacks, and this results in the insufficient bandwidth. So this is something related with the insufficient bandwidth. Now to implement the dual stack, IPv6 needs to be activated in all the network elements, and this will cost on redesign of the existing networks. So complete network should be redesigned. So these are all the different drawbacks, okay, the problems available of dual stack. So as I already told, I am repeating the point, dual stack is a temporary solution. It is not going to be a permanent solution. So it is just a temporary solution. Now, so moving on to the second technique, interoperability technique. Second technique is a tunneling. So here a tunnel concepts will be created. So you can see there are different topology diagram given here. So this is a host to host, host to a router, router to a router. Now let me go for the host to host. So this is a single host. It is a dual stack host. Okay, it can support both IPv4 and IPv6. And other side I have a dual stack host which is supporting both IPv4 and IPv6. Now in between, if you see, unfortunately we have only the IPv4 network we have. So in that case, what I am going to do means I am going to create a tunnel from this host to this host. We are going to take a tunnel. Okay, we are going to create a tunnel. So what is tunnel and all we can discuss in the coming slides. So the tunnel will be used, okay, for sending and receiving the data. That means the packets. Then if you go for the host to router, So host to router means, so from this particular point, from a host to a router, okay, not to the another host. So in between this, we are going to have a tunnel concept, tunneling we are going to have. Okay, you can say this is a dual stack machine. So this machine can support both IPv4 and IPv6. Then this is a IPv6 network. So here only IPv6 is available. In between I have IPv4. Okay, I have IPv4. So what we are going to do means, so between this machine, between the dual stack machine and the router, okay, a tunnel will be created. So this is called, okay, host to router using tunnel concept. Then the next one, router to router. So this is a IPv6 network. The other end is also IPv6 network. In between we are having IPv4 network. Okay, so now I want to transfer the data from 6 to 6, from this network to next network. I want to transfer the data. So in that case, so what I am doing means I am using a tunnel between here. So in the tunnel, the packet will move as IPv6 packet only. Now, so this is called the tunneling concept. Okay, now you can see how the tunneling concept is working. So tunneling means, here we are going to use a concept called encapsulation concept. So what is encapsulation means? So a packet in a packet. Okay, for example, you can keep a IPv6 packet inside a IPv4 packet, or you can encapsulate a IPv4 packet in 6 packet in 4 packet. So this is the concept. Now you can see here. So we are having another topology diagram here to explain this concept. Now this is a IPv6 network and this is a IPv6 network. Okay, I want to send some data from the IPv6 network to here, but in between I am having a IPv4 network. Okay, so this is a IPv4 network. So what I am going to do means, this is a dual stack router. So this router can support both, and this is also a dual stack router, and this is going to support both. Now this is a IPv4 network. So what I am going to do means, I am going to take a IPv4 packet. Okay, I am going to take a IPv4 packet. So this is a IPv4 packet. So it is having a header and the payload. So this is the header part and this is the payload part. Okay, so this is the header and payload part. So what I am going to do means, okay, I am taking, this is IPv4 packet. Now this router is going to encapsulate, it is going to encapsulate the IPv6 packet inside this packet. It is going to do encapsulation. So this is a IPv6 packet, this is. So outside we are having the 4 packet. Okay, IPv4 packet we have. So now encapsulation done. Okay, so now this router, it is doing the encapsulation. Okay, then okay, you can see here encapsulated within the IPv4 network. So IPv6 packet is encapsulated. Now, so the encapsulated packet, okay, it is going to move on in this network. So outside you have IPv4 packet. So there is nothing, no problem here because it is IPv4 network. So automatically the packet will be routed here to this last router. Now, so this router is also a dual stack router. So it can support both. Now this router is going to remove, okay, it is going to do the decapsulation process. Okay, decapsulation process is going on here. So the 6 packet it is going to take out. Okay, it is going to remove from the IPv4. Then IPv6 packet will be forwarded to this local network. Okay, you can see this is the IPv6 packet. It will be forwarded in the local network. Okay, so this is the concept. So encapsulation and decapsulation. So encapsulation means in a IPv4 packet 6 packet will be inserted, or in a IPv6 packet the 4 will be inserted depending upon the situation. Okay, depending upon the situation. So this is called tunneling concept. So tunneling is a safest method. Okay, it is a safest method. Now you can see in the next slide. So tunneling can also be done on a host to router in any situation. In any situation we can do it, but okay, encapsulation must be enabled. That's it. So here it is a very important one. It is going to be the encapsulating. So if without encapsulation we cannot do these particular concepts. So if you go for tunneling, there are some methods available. Okay, so these are all different tunneling methods, or we can say tunneling protocols. Okay, there are a lot of tunneling protocols available. So the first one is a manual tunneling. Second one is a generic routing encapsulation, GRE. Okay, so manual tunneling, GRE. Okay, generic routing encapsulation. So this is one of the thing. Then automatic IPv4 compatible tunnels. 6 to 4, this is one type of protocol. Okay, ISA-TAP, intra-site automatic tunneling. Okay, automatic tunnel address. Okay, automatic tunnel addressing protocol. So these are all the different protocols available. So you can use anything. Most of the protocols it is okay by the Cisco. Okay, Cisco proprietary protocols only. So any different types of tunneling we can use it. Now I'm going for the third method. So the third method of interoperability technique is translation technique. So what is translation technique means? Converting. Okay, so we are going to convert. Okay, converting from 4 to 6 or 6 to 4. Okay, that is going to be the translation technique. So now you can see the topology diagram here. So there is a topology diagram given. So according to this topology diagram, so we are having a IPv6 network. So this is a completely IPv6 network. Okay, the other side I am having a IPv4 network. Okay, this is the 4 network. Now from IPv6 to IPv4 I want to send a data. Okay, so this machine, okay, or this device, okay, that means the router is not a dual stack. It is not a dual stack. Okay, so the other side, this side, okay, it is IPv6 is configured and here IPv4 is configured. So what is going to happen means all your address, okay, you can see here NATPT, network address translation, port translation. That means 6 address will be converted into 4, 4 address will be converted into 6 in this particular device. So there are different techniques available how to convert. Okay, it is we are not covering that part here, but how to convert a IPv6 address into 4 and IPv4 address into 6. Okay, how to convert, there are a lot of techniques available for that. So using any of the technique, okay, so the addresses will be converted here. So this is called translation techniques. Okay, now you can see in the next slide. So here what we are going to use, it means we are going to use NATPT, network address translation, port translation. So this is one of the very important technique. Okay, so by using this particular concept you can convert all the 6 addresses. Okay, 6 addresses mapping to the IPv4 addresses and 4 mapping to 6. So it will be done by using these particular concepts. There are some challenges. Okay, challenges available while implementing the translation technique. So generally, okay, so we cannot say it's myth, it is actually fact. What does that means? If you are going for translation techniques, so it will slow down the packet movement. That means it will take more time. The reason is, so whenever the packet reaches, okay, either 4 or 6, okay, you can take it anything. Whenever a packet reaches the router, so the router is going to map. So there will be a pool of IP address they will maintain. Okay, so IPv4 or IPv6, what they will do means they will maintain a pool of IP address. So from the pool of IP address, they have to assign a particular IP address, okay, for a particular 4. Okay, you take 4 to 6, for example. So a 4 is coming, IPv4 is packet is coming and requesting for a equivalent IPv6 means, so there is a mapping going on here. So from the pool, they will take a address and they will map it. So for that mapping, okay, it is going to take some time. And that mapping should be registered, it should be recorded, because while coming back, while the packet is coming back, again it has to map. So generally it will slow down, okay, the packet flow. Okay, this is one of the challenge of the translation technique. Then if you see the second one, okay, you can say this, they are not expected to used widely. Okay, it is not widely used because they slow down the packet flow. Then translation technique do not allow the network to exploit the specific capabilities of either protocol. So both the protocols, okay, it is going to be like what to say, if you are having both, don't be like why, okay, how to say that, don't be gray, okay, be black or white. So this is a correct sentence. Okay, the second, the correct quotes, okay, it's fitting here. Don't be gray, be either white or black. So you can go for either 6 or 4. So if you are using both, okay, there will be a lot of issues available. They act as a redundant channel in the online communication over the internet. So these are all the different challenges. Okay, the challenges if you are implementing the translation technique we have. Okay, now so with this we are completing 3 different interoperability techniques. Okay, so we saw what is the drawbacks of each method. Now I am going for the next one, transition richness. Okay. So since the internet consists of hundreds of thousands of IPv networks and millions of IPv nodes, the challenge for transition from 4 to 6 lies. There are different challenges available. So what does that means? So starting from renumbering, okay, that means millions of people are now in IPv4 networks. So if you are taking them to the IPv6 means definitely assigning the IP address for all, okay, it is going to be a challenge. Then router upgrades. This is a very big challenge because in IPv6 a different set of routing protocols, for IPv4 a different set of routing protocols. Now we have to remove or we have to change all the routing protocols in the routers, we have to change. Then protocol conversions. There are some set of protocols it will work on IPv6, some set of protocols which will work on only IPv4. So we have to convert all the protocols. Then the client's support. So that means the users support is very, very important. So these are all a different challenges available for moving from 4 to 6, but anyway in a very less time. Okay, so in another 4-5 years definitely all will move to the IPv6. Then future of IPv addressing. So this is what we are discussing now. So everybody is having a device. Okay, so everybody started using the mobile phone and connecting with the internet so very easily. So IPv4 address is not enough. So it is exhausted completely, it is over because of the number of devices. IPv4 is not supporting the too much of IP addresses. It's already exist. So already completely over, exhausted. Okay, so there is a need to move from 4 to 6. So the 6 address space is very large comparing with the 4. Okay, you can see all the points here. So because of the smartphones, okay, gaining the popularity in the recent years, so people are started, okay, nowadays internet become life. Okay, internet become life. So for everything now we are started using internet, even from banking to education to, okay, social medias, anything. It's whatever it is going to be the internet. So without internet there is no life. So automatically the number of users are increasing. If the number of users increased, automatically the number of IP address, particularly public IP address, more we need. So it is exhausted, go for the next version. Okay, IPv6 is a solution for this. Now, so pros and cons of practical transition from 6 over 4. Okay, what are the issues available means? The first issue starts with the ISPs, internet service providers. So your internet service provider must support, okay, must enable IPv6. This is the first thing. Then, so based on that, your internet service provider, that means the transition problem faced by the ISPs include the following areas: in the network, connectivity, applications, network management and operations. So in all these areas your network service provider is having the problems, they are facing the problems. Okay, starts from the network, connectivity, applications, network management and operations. So if you see the network problems particularly, so address architecture, that means based on the version of the protocol, there are a lot of changes you must do in your network. Connectivity problem, high availability, then application problems, network management and operation problems. So these are all the problems which are available, okay, while moving from 4 to 6, but we have to do, okay, we have to do. So nowadays if you see the lot of IT certifications, so they are giving more important for the 6. Okay, they are giving some weightages. Now the weightage for the IPv6 part is increased. So everybody must know that, okay, everybody must learn, okay, IPv6 types, configuring, subnetting, so everything. Now in the next slide we are having a very simple example. So in a router, how to configure a IPv6 address and IPv4 address. Okay, they are giving a small comparison here. So interface fast Ethernet 0 by 0, this is the name of the interface. So the IP address is 10.10.10.1. So this is a IPv4 address with subnet mask. Okay, 255.255.255.0. Okay, this is a class A IP address, but they have done some subnetting, so they use 255.255. So they borrowed some bits. So how many bits they borrowed means here 8 bits, 8 bits. So totally 16 bits. Okay, they borrowed here. Okay, so this is a simple example for IPv4 address configuration in a router. So if you are going for 6, okay, if you are going for 6, okay, how to configure the IP address means you can see IPv6 address, okay, IPv6 address, this is the command. So 2001:12:, okay, they have one, so this is the IP address, and /64 is the prefix, okay, it's a prefix, okay. So this is how to configure the IP address in IPv6. Now this is the second part. Now we are having another two examples here. So they are having a show command, show IP interface fast Ethernet 0/0. So this will display the information about this interface, okay. This is for IPv4, okay, this command is used for the IPv4. For IPv6 the command is show IPv6 interface fast Ethernet 0/0. So the set of commands is going to change, the protocols is going to change, okay. There are plenty of changes will be available in IPv6, but we have to go for 6 in the future. So almost most the big corporates now already they started implementing 6, okay. So people are moving to 6. In another 4-5 years of time everything will be completely changed to 6. So what we discussed in this lecture means we discussed the three major concepts, okay. What is dual stack, and second one is the translation, and third one is the tunneling. So these are all the different interoperability techniques available. So thank you very much, keep watching.